Before we formally introduce the next unit, let's consider one of the most well-known reactions in chemistry, the synthesis of water. Now, as with all chemical reactions, we can break this down into multiple reactions. So if we consider hydrogen gas, in order to make water, we would need to break hydrogen gas down into hydrogen ions like so, and likewise, in order to make water, we would need to break oxygen gas down into oxygen ions like so. The problem is, if we just look at these two reactions here, we can see that the charge isn't balanced in the case of either reaction. So in order to balance out the charge, in order to negate the positive charge in the hydrogen equation and balance the negative charge in the oxygen equation, we can simply add electrons to either side of the equation, as electrons are where most charge comes from anyway. So we can see that the hydrogen ions together have a charge of +4, while the oxygen ions here have a charge of -4. So that means in the hydrogen equation, we would need to add 4 electrons on the side of the hydrogen ions, because +4 minus 4 is equal to 0, and now our charge is balanced. Conversely, with the oxygen equation, we can add 4 electrons into the reactant side, and that way both the reactants and the products have a charge of -4. Now, another way to express this is to talk about what is happening to the reactants, hydrogen and oxygen gas in each case. We can see that electrons are actually a product in the hydrogen reaction, and hydrogen has a positive charge while it started out as neutral, so we can conclude that hydrogen gas is losing electrons, while oxygen gas, we see that the electrons are in the reactant side, and oxygen has a negative charge in the products compared to being neutral in the reactants, so we can conclude that oxygen is gaining electrons. What we have just introduced is the next unit, which is what we call electrochemistry, and as the name might suggest, electrochemistry is the branch of chemistry that is specifically concerned with the gaining or the losing of electrons. In other words, how electrons move from one element or compound to another over the course of a chemical reaction. Now, in every branch of chemistry, we have new ways to analyze reactions and new reaction types. So if we consider the oxygen reaction, this is what we call a reduction reaction, and a reduction reaction is simply a reaction in which we have an atom that gains electrons, as we see with oxygen, because electrons are a reactant that goes to the oxygen, and oxygen has a greater negative charge than it started out with here. And again, if we look at the root of the word reduction, we can see that the root is to reduce, and we can show that oxygen has been reduced because it has a lower charge than it started out with. Now, conversely, the hydrogen reaction is where hydrogen has lost electrons, or rather an atom loses electrons, and therefore we call it an oxidation reaction. The name for this is a little bit less intuitive, but will be explored in the following video. Now, for those of you that are wondering how each of these reactions does not violate the law of conservation of mass and the law of conservation of energy, don't worry, there is a way. Now, obviously, we can't just make up electrons. We can't just take 4 electrons from nowhere and give them to oxygen, as it would violate the law of conservation of mass and energy. What this means is that individual oxidation and individual reduction reactions cannot happen by themselves. We can get electrons to use in a reduction reaction by taking them from the oxidation reaction. So if we take these electrons that are lost in the oxidation reaction of hydrogen and transfer them to the reduction reaction where oxygen can use them and therefore gain electrons, we can effectively combine these two reactions into a single reaction. And when we do that, when we combine one oxidation and one reduction reaction, we collectively call that a redox reaction. Again, this is literally a portmanteau of reduction and oxidation to show that one element or compound in the combined reaction is reduced and the other element or compound in the combined reaction is oxidized. And we can show what the redox reaction is by simply adding our two reactions together. So if we put both of our reactants together, we get 2H2 plus O2, hydrogen and oxygen gas respectively, go to 4H plus 2O2 minus, and of course we have 4 electrons on either side. But because the same number of electrons appear as a reactant and a product, we can cancel them from the overall reaction, and the resulting reaction that we get has its charge balance. We can see that 4H plus ions gives us a charge of positive 4, 2 oxygen ions gives us a charge of negative 4, positive 4 minus 4 is a charge of 0, so our overall reaction is balanced. Now, because we can come up with this overall redox reaction by taking one reduction reaction and adding it to one oxidation reaction, that's why we call each reduction-oxidation reaction pair, we call them half reactions, because again, each individual reaction cannot happen by themselves. The electrons in the oxidation reaction have nowhere to go unless we pair them with a reduction reaction, and conversely, we can't just make electrons out of nowhere. We need an oxidation reaction to supply the reduction reaction with electrons, which is why each half reaction is needed to work together in order to give us the combined redox reaction. In the next video, we're going to be expanding upon this concept further and looking into more detail about what reduction and oxidation reactions mean and how to identify whether a reaction is a reduction or oxidation if we cannot see electrons in the reaction.